All right, there's a lot going on with logarithmic differentiation. Probably at first glance, what we just did didn't feel much easier than using product and quotient rules. It actually does make some of those problems a lot simpler. It just takes a little bit of getting used to. But there's so much going on, I want to just focus on my rules and my standards for using this. Number one, you must take the absolute value, even though it's going to drop out. If you completely forgot to take the absolute value and you just took the log and then took the derivative and solved for y prime, you'd get the same answer. You would not get the same grade. Okay? Now, I warn you, the book sets a horrible example here. They say in the text, if we had something negative, we could just take the absolute value and then it would drop out when we took the derivative. But they don't actually show that. That's horrible. Okay? Not because it's going to lead to the wrong answer here, but because it's going to build the habit that you think it's okay to go around taking the natural log of anything you want to. And here, you can get away with that and get the right answer. But in other contexts, if you try to take the natural log of something that's negative, you're making up gibberish. It's going to lead you down the wrong path. That's a habit you don't want to get into. So even though it doesn't affect the answer, taking the absolute value ingrains in your head, I can only take the natural log of something that's positive. Okay, my second rule, if I tell you to use logarithmic differentiation, so if I give you a problem and I say take the derivative using logarithmic differentiation, okay, and you're doing that for a bunch of products and quotients, I expect you to use the rules of logs to simplify things as much as possible. Okay? So I want you to use the quotient rule, use the product rule, use the power rule. Okay? You could get the same answer. You know, in the last case, we could have just used the quotient rule, and then we would have had the natural log of the quotient on top, and we could have used, sorry, not the quotient on top, the product on top. We could have used product and chain rule there. I want you to use the rules of logs to make it as simple as possible. Okay. And then my third rule is if I just give you something that involves a bunch of products and quotients and it's your choice to use logarithmic differentiation. It's a legitimate technique. You can make that choice, but then I want you to write in the caveat that the result may or may not be valid if the function is 0. Okay. Most of the time you can simplify it to something that will be valid if the function is 0, but I just want you to write this in again so that you're thinking it. I won't require that if I'm telling you to use logarithmic differentiation, but there's a good chance that if I tell you to use logarithmic differentiation, I might also include a short answer question that says something like, the result you got using logarithmic differentiation may or may not be valid if y is what value? So I could ask you a short answer question about this caveat. I won't require that you write it in if I'm telling you to use logarithmic differentiation, but I will require that you write it in if it's your choice. And if you don't remember when I don't just write it every time. It's certainly not wrong to write it if I'm requiring the logarithmic differentiation. In fact, it's probably a good habit to just write it every time.